Hello and welcome to today's session. We'll wait for a few more minutes until some of people join. Okay, so welcome to the week 4 problem solving section for availability and management of groundwater resources. So this week we'll be discussing about probable questions that uh, can come in your assignment that is related to the portions that were covered in this week's lecture, which is lecture 15 to 19, and it is about confined and unconfined aquifers and their parameters. So we'll be dealing with few questions, sample problems that will help you in solving the assignments. So we'll start with the problems. So as always, I'll be showing you some questions, and if you know the answers, you can put the answers in the chat box so that it'll be a practice for all of you as well as an interactive session. We can keep it a little more lively. So we can start with the question discussion. So the first question is, what is the quantity of water that a unit volume of aquifer drains by gravity called? Hi Danes, welcome to the session. You can see some questions on the screen. You can drop in the answers in the chat box. That's how the session is going to go about. So the first question is, what is the quantity of water that a unit volume of aquifer drains by gravity called? So it's called porous volume, water yield, specific yield, or unit yield. Right? So let's move on to the solution. So in the earlier classes also we had discussed about what specific yield is and what specific retention is. So specific yield as per definition is the amount of water per unit volume that will drain from an aquifer under the influence of gravity. So if you see here, if you are taking one unit volume of aquifer material, or one unit, say it can be 1 meter cube or 1 centimeter cube or 1 feet cube, a unit volume is considered, then from this unit volume, how much amount of water goes, or how much amount of water is draining from this unit volume of the aquifer under the influence of gravity, where there's no other forces applied, but under the influence of gravity, how much of water is getting drained from this unit volume of aquifer. The amount is called as the specific yield. And the specific yield is given by the volume of the water drained to the total volume of the aquifer material. In association with the state, this term, we also studied about what specific retention is. Specific retention is the amount of water that is retained on the aquifer. Now, again, if you consider one volume of 1 meter cube or 1 centimeter cube or 1 feet cube of aquifer material, after all the water that is drained by gravity is gone, what amount of water is retaining back in the soil or in the aquifer is called as the specific retention, and it is given by the volume of water that is retained back to the soil by the total volume of the aquifer material. And the sum of the specific yield and the specific retention is equal to the porosity of the aquifer material. So we had studied all these topics in the previous sessions. So this is something that we very commonly see repeating in almost all of the sessions, and that itself shows the significance of these terms and these parameters. So it would be good if you familiarize it. So the answer again said is specific yield. Moving on to the next question. Specific yield for an unconfined aquifer, is it greater than porosity? Is it less than or equal to porosity, or is it equal to porosity or unrelated to porosity? I had just shown a relation which is associating specific yield with porosity, and right, your answer is correct. So let's see the explanation for this. So specific yield is less than or equal to porosity. So we can see here the relation between porosity, specific yield, and specific retention. So specific yield plus specific retention is equal to porosity. So mathematically, if specific retention is equal to 0, then specific yield will be equal to the porosity. Say if it is not equal to 0, then specific yield will be less than porosity. So the correct answer is less than or equal to porosity. Third question, a perched aquifer is an aquifer that is found above the water table, within an aquifluid, below an impermeable layer, or none of the above. Again, 4 types of geological formations that we studied about were aquifer, aquitard, aquiclude, aquifuge. And out of that, we studied about a perched aquifer, right? So let's see about perched aquifers once again. So perched aquifers are a special kind of aquifers that is occurring above the water table when there's a piece of impermeable formation that is available above the water table, above the unconfined aquifers. So what happens is when the water infiltrates through the soil, some of the water will get accumulated over here, and such an aquifer is called a perched aquifer. So this kind of water is it's a very small quantity of water, and generally what happens is when you drill bore wells and all, or tube wells, this aquifer is reached fast. So people always tend to misunderstand this aquifer for a confined aquifer, as a result of which, but unfortunately the water quantity will be very less in it, and also it will not stay for a long time. After a period of time, the water will not be available, and it's only until the next precipitation event that water will again get accumulated in here. So First, aquifers are generally found above the water table, where an impermeable layer is formed and water gets accumulated in. So that answer is also right. Moving on to the fourth question. Aquifers are distinguished into how many types on the basis of physical conditions under which water can exist in them? Here we're talking about aquifers. So how many types of aquifers are available based on the water category? Again, right? The answer is B. So there are two types of aquifers that we have learned about. One is the confined aquifer, unconfined aquifer. Confined aquifer is the one which is between two impermeable layers, and unconfined aquifer is one which has an impermeable layer on the bottom and water accumulates on top. So that is the right answer. Moving on to the first question. What is the pressure of upper surface of an unconfined aquifer? Again, a very repetitive question that has been in the loop in the past few lectures. Is it does the water in the unconfined aquifer have a high pressure? Is it lower than atmospheric pressure, equal to atmospheric pressure, or greater than atmospheric pressure? So right, it is equal to atmospheric pressure. So as you can see over here, I'll introduce one more term associated with this. So unconfined aquifers, the water is always, the water table is subjected to atmospheric pressure. But when it comes to a confined aquifer, since it is sandwiched between two impermeable layers, the water is under a pressure that is not equal to the atmospheric pressure. It can either be a low pressure or it can be at a higher pressure. So now, suppose we insert some, you drill tube wells into these confined aquifers, and then you check what is the pressure head at these in these bore wells or tube wells, or the level of the water in these tube wells. And when multiple number of tube wells are drilled into these confined aquifer, by knowing the level of the water, the pressure head of the water in all these tube wells, the line, imaginary line that is drawn indicating a total energy or total pressure of the water is called as the potentiometric surface or the piezometric surface. So basically piezometric surface because the process potentiometric method is what is used to find out what is the water level, the potential water level in confined aquifers. So like I said, when tube wells or bore wells are inserted into confined aquifers, the water is either going to be higher than the water table or lower than the water table. If you see over here, B, the well B is drilled into confined aquifer and it is having the water level lower than the water table, which is indicated by this blue line. Again, if you see over here, this tube well has water that is higher than the water table and water level is over here. So the same way, if we are able to find out the pressure or total pressure head or energy of waters along this confined aquifer, then we will be getting this line, which is indicating the total energy of the confined water in the confined aquifer. So this line is called the potentiometric surface of a confined aquifer, or it is also called the piezometric surface of a confined aquifer. This is another pictorial representation of that. You can see here, this well is actually having a pressure that is greater than the atmospheric pressure, due to which the water is going to come out of the well, and this surface is noted. Then in next tube well, the water level is coming just above the water table. So in the same way, if number of tubes are inserted over here, you will get that the water table is along this dashed line. So a well through which water will gush out or water starts coming out, flowing out is called an artesian well. Flowing artesian well, sorry, and such wells where the water level is greater than the water table level is called artesian well. If you see here, this tube well is being inserted in the unconfined aquifer and the water will be at this level, which is corresponding to the water table level. So the pressure of upper surface of unconfined aquifer is equal to atmospheric pressure, and the pressure of water in confined aquifers will be less than or equal to or greater than atmospheric pressure. It can be of any differing pressures. Now, supplies from first water table are reliable as a source of water. Is it true or false? Correct. So we just talked about first aquifers where the water available is very less quantity, as well as the fact that it is not going to be available for a very long period of time. So it is not a reliable source of water. So the correct answer is false. Seventh question. What is the upper surface of water in a confined aquifer called? Is it called the primary layer, secondary layer, first layer, or piezometric layer? Right? So we just learned about the potentiometric surface and piezometric surface and how it is found and what is that surface called as in confined aquifer. So like I said, potentiometric surface is the level of the water there, that imaginary line that is representing the water level in the confined aquifer. It is also called as piezometric surface, and or the layer or the level can also be called as piezometric layer of water. Again, it's called piezometric surface. It is another term for potentiometric surface, that is defining the level to which water in a confined aquifer will rise if it was drilled with wells, and if it is lying above the ground surface, it is called a flowing artesian well, which I had shown in the diagram earlier. This diagram. So this one is called a flowing artesian well because it is lying above the ground surface. Question number 8. High porosity is alone sufficient to ensure water yield in an aquifer. Is this true or false? Correct. It's not true. So porosity is just one of the important parameters that that we can say to that we can use to signify the importance or the signify the quality of the aquifer. So there are a lot of properties or parameters on which an aquifer can be, an aquifer depends on. Porosity is just one of the important parameter. Another parameter is permeability. It also depends upon the type of soil. So all those are important parameters related to the aquifer. So it is not just sufficient to understand the porosity alone to decide how much of water an aquifer can yield. So even if it is of high porosity, if it is a less permeable, permeability is nothing but the ease with which water can flow through aquifer. So if it is a less permeable of aquifer, then it need not give us enough water. So porosity alone or high porosity alone is not sufficient to ensure water yield. So the correct answer is false. Now, streams that contribute to the groundwater are called as. What are streams that contribute to groundwater called as? They're called effluent streams, groundwater streams, influent streams, or perennial streams. A or D, okay. See. So let's get into the explanation of this. The answer is C, influent streams. So let's just go through each of the term. So there are two types of water movement between streams and groundwater. The one is where the stream is giving water to the ground, to the groundwater aquifer. That is, water from the streams is going below to the ground. And another where the groundwater is providing water to the stream. So the kind of stream where the streams are augmenting the aquifer with water is called influent stream. That is, groundwater is getting water. So it is stream to groundwater and it is called influent stream. And the kind of system, the movement where the groundwater is providing water to the stream is called effluent stream. So like you can see here, influent or losing stream is also what uh, is how it is mentioned. So influent or losing reaches lose stream water to the aquifer. That is, water will go from the stream to the aquifer, and effluent or gaining reaches will receive discharge from the aquifer. So the question here was streams that are contributing to groundwater. So it comes under this category where the stream is providing water to the aquifer. It is called influent stream. And let's take a look at the other terms. Effluent stream, water, the groundwater is providing water to the stream. Now, what is a perennial stream? There are also three other terms associated with the streams. Let's have a look at it. So, ephemeral streams are streams which are prominent only immediately after a precipitation event occurs. So, such streams are called ephemeral streams, and they don't last for too long, maybe less than 30 days per year. So, this happens only immediately after when a precipitation event occurs. These streams will be rich in water. Now, intermittent streams are also something like that. Seasonally, these streams will be available. In the dry seasons, these streams tend to dry out and there will not be any flow of water or water available in such streams. These streams are called intermittent streams. How is it different from ephemeral streams is that they can last longer than 30 days per year. These are seasonal, these streams appear during the season. It will last for the entire season. But in case of ephemeral streams, it's not like that. One precipitation event will occur, and then that time the stream will be rich in water, but after a few days it will drain out or dry out. Now, perennial streams, on the other hand, are streams that are available throughout the uh, throughout the year, no matter whether it is a monsoon season, wet season, dry season, or anything. So these are the terms associated with the streams. So the next question is, the rate of groundwater movement is given by what? The hydraulic conductivity of an aquifer, hydraulic gradient, storage capacity of an aquifer, or both A and B. Okay, so the answer provided is both A and B. Correct. The answer is hydraulic conductivity and hydraulic gradient. So let's get into these terms. So the hydraulic rate of groundwater flow, that is, what is the velocity or the discharge rate of groundwater flow, is given by a very important equation called the Darcy's equation. He was a he devised this equation. So there are, let's look into the terms that are associated with the Darcy's equation. So in Darcy's equation is given by V is equal to K into I, or it is also given by Q is equal to K into I into A. So V here indicates the velocity of the flow of groundwater. The capital K here indicates hydraulic conductivity. Hydraulic conductivity is nothing but how the permeability of an aquifer is expressed. Permeability is nothing but it is the ease with which water will flow through the aquifer. So how easily water can flow through the aquifer is given by the property called permeability of the aquifer. So permeability of the aquifer is expressed in terms of hydraulic conductivity, and capital K is the is the letter that is used to represent hydraulic conductivity. Now you can see it is multiplied with a term called I, which is which indicates hydraulic gradient. Now let's see what hydraulic gradient is. So hydraulic gradient is nothing but it is the ratio of the change in the hydraulic head to the length of the aquifer. Now, what is this difference in the hydraulic head? So suppose if you consider this as an aquifer and you see that water is going to flow like this through the aquifer and come out like this. If you insert a piezometer over here, you will find the pressure is at this level. And then if you insert a piezometer at the outlet of it and you see the pressure head is at this level, then the difference in pressure head is what is the numerator of this hydraulic head is indicating. And the length, entire length between these 2 points is what the delta L is indicating. So hydraulic head is nothing but the difference in pressure to the length of the aquifer is what is called hydraulic gradient. So here V is equal to Ki. K is representing hydraulic conductivity and I is representing hydraulic gradient. Now we also know that velocity is equal to discharge by area. So if we put this equation in here, we will get that discharge is equal to K into I into A. So supposedly, if there are problems that are coming asking you to find the discharge, you will have to use this formula. If they're asking you to find the velocity, then you will have to use this formula, K into I. And for discharge, it will be hydraulic conductivity into hydraulic gradient into the cross-sectional area of the aquifer. So this is how Darcy's law is explained. Now the next question is, the change in the head per unit distance is given by what? Is it the hydraulic gradient, equipotential gradient, flow gradient, or the hydraulic head? You're right. The answer is hydraulic gradient. Same for the explanation that I gave on this earlier. So the next question. Darcy's law is one of the following. Is the discharge says that the discharge is inversely proportional to head loss. Discharge is inversely proportional to head loss and directly proportional to length. Is directly proportional to head loss and inversely proportional to area of flow and to the length of the path. Discharge is directly proportional to head loss and area of the flow and inversely proportional to the length of the path. What would be the answer? Okay. So the right answer is option D. We learned about how Q is equal to K into I into A. I is equal to delta H by L. So Q is directly proportional to the head loss, which is given by delta H, directly proportional to the cross-sectional area, and inversely proportional to the length of the flow path. So the correct answer is option D, directly proportional head loss and area flow, and inversely proportional to the length of the path. Moving on to the next question. The velocity of flow of water V through a soil stratum of permeability K and porosity N as per Darcy's equation is given by. So right, the correct answer is A. Velocity is equal to the permeability into hydraulic gradient. So one thing we can see that velocity of water with flow velocity is independent of the porosity. It is not dependent on the porosity, but it is dependent on the permeability as well as the hydraulic gradient. Next question. When groundwater is flowing into a stream to augment its discharge, then what is the stream called? Right? So the correct answer is an effluent stream. We learned about an influent stream, giving what the stream is providing water to groundwater. Effluent stream, the groundwater is providing water to the stream. Perennial stream, which is present all over the year, doesn't irrespective of the wet or dry season. And an ephemeral stream is a stream that appears only after precipitation event occurs for a few days, mostly generally less than 30 days. An aquifer which is confined at its bottom but not at the top is called a semi-confined, confined, unconfined, or none of the above. Correct. It is unconfined aquifer, something that we have studied over the weeks. An example of acutard stratum in the ground profile is a layer of granite rock, clay, sandy clay, or sandstone. Okay, so hello Karthik, welcome to the session. If you're staying back, we'll go through the questions once again. So let's wait till this question completes. So let's go into the. So let's just refresh what all the terms are. Aquifer is what we all know. It is a geological formation that is consisting of plenty of water. It can transmit water as well as store water to a significant extent. Acutards are formation which also consists of water, but the water movement in it is water transmission or water yield is very insignificant when you compare it with an aquifer. It doesn't yield as much water that an aquifer yields. Now, aquiclude are impermeable formations which will have water, but they cannot transmit. Water movement to them is not possible. And aquifuge are impermeable formations which cannot contain water. They cannot store water also. They cannot transmit water also. So some examples of aquifer are sand, gravel, etc. Acutards are clay lenses interbedded with sand. So if sandy materials have some portions of clay portions in between them, then it is called an acutard. Or if the uh, clay silt interbeds, sandy silt interbeds, all are coming under acutard. Acucludes are clay. Examples for acucludes are clay materials, and acufuge is granite rock and everything. So the correct answer for this option is for this question is C. Granite rock is coming for acufuge. Clay is coming for acuclude. Sandy clay is for acutard. And sandstone and everything is for aquifer. Not sandstone is not for aquifer. Sand is for aquifer. Sandstone, I'm not sure for which category it comes. But sandy clay is what comes for acutard. So that's the round of questions. If you want to stay back, Karthik, I can just go through the questions from the beginning. I'm not sure about sandstone. So I'll just confirm and put it in this slide itself. What is sandstone? Does it form an aquifer or is it an aquifer? Where when you get the presentation uploaded in the Google Sheet, I will have the answer written in this presentation. I have to just see if it is aquifer or okay. So let's go through the questions once more. This is for people who have joined earlier, I mean later. Danes, if there's not, if do you have any doubt regarding the questions we discussed now? If you don't have any doubts, free to go. If you have any doubts, please let me know. So these were the questions that we discussed in the beginning, from the beginning. What is the quantity of water that a unit volume of aquifer drains by gravity called? If you know the answer, please put it into the chat box. So we are talking about what is the amount, the quantity of water that a unit volume of aquifer drains by gravity called? Is it porous volume? Is it water yield, specific yield, or unit yield? Karthik, if you know the answer, just drop it in the chat box and then we can go on to the solution. Okay, right. So specific yield is the amount of water that is drained of a unit volume of an aquifer under the influence of gravity. A pictorial representation for that is this. If you are taking 1 unit volume of an aquifer, and then seeing how much of water is coming out of it under the influence of gravity, then that amount of water is called the specific yield. And specific retention is whatever amount of water is left back after this gravitational water is lost. The relation between specific yield and specific retention is the sum of specific yield and specific retention is equal to the porosity, as given in this expression over here. So the correct answer is C. Specific yield, second question. Specific yield for an unconfined aquifer, is it equal to or less than porosity, greater than porosity, unrelated to porosity? Okay. If you don't know the answer, just type in that you don't know. Okay, I'll move on to the solution then. It's not wasting so like I said, specific yield and specific retention are associated, are related in this way. The sum of the specific yield and specific retention is equal to porosity. Now, if specific retention is equal to 0, then specific yield is going to be the porosity. Now, specific retention is not equal to 0, specific yield will be less than the porosity. So, the answer for this will be option B, it is less than or equal to porosity. Third question, a perched aquifer is an aquifer. Where is it found? Is it found above the water table? Is it found within an aquiclude? Is it found below an impermeable layer, or is none of the options right? Correct. Perched aquifers are aquifers that are formed generally above the water table. What is happening is one small impermeable formation will be there above the water table, as a result of which, when there's a precipitation event occurring, water will infiltrate and it will accumulate uh, in this impermeable formation instead of going down to the unconfined aquifer. So this water is often mistaken as aquifers when tube wells and all are drilled in, but they are not very good sources of water, because it is water only stays for a minimal amount of time and only a minimum quantity of water is available in such purged aquifers. So generally they are found above the water table. So the correct answer for this question is option A, above water table. Okay. Fourth question, aquifers are distinguished into how many types on the basis of physical conditions under which water can exist in them? How many types of aquifers are there as a question? Okay, so here we are talking about aquifers. Maybe you got a little confused with the geological formation. If you're talking about geological formation, we are studying about 4 to 5 geological formations: aquifer, acutard, acufluid, aquifuse. We are also learning about first aquifers. But when it comes to aquifers, there are two types of aquifers. One is the confined aquifers, the other is the unconfined aquifers. So confined aquifer is nothing but when two impermeable formation, when there is an aquifer or water existing between two impermeable formations, then it is called confined aquifer. And there's only one impermeable formation, and then water is getting accumulated on top of it in the soil stratum. Such an aquifer is called an unconfined aquifer. So there are two types of aquifers when it comes to the existence of water in them. One is the unconfined aquifer, where the unconfined aquifer with the water table exposed to atmospheric pressure, and the confined aquifer, which is under some kind of pressure. It is either low pressure or higher pressure, or sometimes also equal to atmospheric pressure, but the pressure variation is always there. So the correct answer for this is aquifers are distinguished into confined and unconfined aquifers. Now, if you see a perched aquifer, it is also one kind of an unconfined aquifer because on top there's no impermeable formation coming. So that water is also going to be under atmospheric pressure only. Again, like how we discussed. What is the pressure of the upper surface of an unconfined aquifer? We just talked about it now. Is it under high pressure, lower than atmospheric, equal to atmospheric, greater than atmospheric pressure? Okay, so I'll explain once again. So if you can see the figure in here, you can see the dark, bright yellow is confined aquifer. That is, it is having a confining gray layer and another layer underneath, as a result of which, and the aquifer material is between these two impermeable layers. Such an aquifer is always under pressure. Now, when you look at the unconfined aquifer, where there's no confining layer on the top, the water table is always going to be under atmospheric pressure. If you check, if you insert a piezometer, that is, you drill a hole here, and if you insert a piezometer, that piezometer is always going to show atmospheric pressure reading. Now, at the same time here, if you see, when you insert a piezometer into a confined aquifer, it can show the pressure head higher than the water table, or it can show the pressure head lower than the water table also. So the pressure is going to be always varied in a confined aquifer, whereas in an unconfined aquifer, it is always going to be under atmospheric pressure. Now, suppose we are drilling so many boreholes along this aquifer, and then we are marking the water level of every borehole or tube well or whatever it is that we are inserting into this aquifer. An imaginary line that is drawn connecting all these water levels is called the potentiometric surface or the piezometric surface of a confined aquifer. And all this line is indicating, this imaginary line is indicating at what level the water will reach. If there was no confining layer, what is the level of water going to be if a tube well is going to be inserted into a confined aquifer, is what information we can achieve from this potentiometric surface or confined aquifers. So the this imaginary line that can be achieved if we connect the water levels of various tube wells or piezometric tubes that are inserted into the confined aquifer is called the potentiometric surface, or it is also called the piezometric surface. So again, here you see the water table is at this level. So if you if you dig a well over here, the water level is going to be at this level only. But at the same time, if you dig a well into this confined aquifer, because of the pressure, the water is at the confined aquifer, the water is going to flow out. It either flow out. When it flows out, it is called a flowing artesian well, or it will be below the surface. That time it is called an artesian well. Now, suppose you insert one tube well over this line, you will find the water level is at this point. So this information can be achieved by drawing the potentiometric surface of an unconfined aquifer. So the answer for this is equal to atmosphere. We are talking about unconfined aquifer over here. So the pressure of the upper surface of unconfined aquifer is nothing but it is the water table. Pressure of water table of an unconfined aquifer is at atmosphere, equal to atmospheric pressure. Next question, supplies from the first water table are reliable. Are they a reliable source of water? Is it true or false? That's the question. So supplies from a perched water table are not reliable sources of water. The answer is false. It is because, like I said in the earlier slide, you see here, quantity of water found available in this type of aquifer is always minute and available for only short periods of time. So this water is not a huge quantity of water when you compare it to the unconfined aquifer. There will be small rock surfaces on top of which water will get in between the soil, on top of which water will get accumulated. Say this drains out, or it can be near to the surface, it can get evaporated, or say if you're having a well there, that water can be easily over with because it's going to be only a small quantity of water. So it is not a reliable source of water. We can get water, but it is not a very reliable source of water. It is not going to last for a long time. So the answer for this question is false. Uh, if you say can it act as a source of water? Yes, to some extent. But is it a reliable source of water? No. Next question, what is the upper surface of water in a confined aquifer called? Again, we discussed about potentiometric surfaces of confined aquifer. Right? It's called piezometric layer. We discussed about water potentiometric surfaces, water piezometric surfaces. Potentiometric surface is another name for piezometric surface. So we can call it piezometric layer also. High porosity is alone sufficient to ensure water yield. Is this statement true or false? So again, porosity is just one of the properties of an aquifer. There are various properties to an aquifer. Porosity is one. But by just knowing if the material is highly porous or not is not enough to ensure whether the water yield will be good or not. So there's a property called permeability with which the ease with which water will flow through the aquifer. And then also it is important what the material of the aquifer is. So all these also have a role in deciding the water yield from the aquifer. So high porosity alone is not sufficient. High porosity, the permeability, the material, everything is also playing a role in the water yielding capacity of an aquifer. So for this question, the correct answer is false. high porosity alone is not sufficient to ensure water yield. Now, next question. Streams that contribute to the groundwater are called as, what are they called as? Okay, so correct answer is C. Let's see what are these influent streams, effluent streams. Correct answer over here is influent streams. So there are two types of water movement between a stream and the groundwater. A stream is a surface water, and groundwater is under the surface. So when the water in the stream flows down and recharges the groundwater, then it is called an influent stream. That is, water from the stream is going down into the ground, going and supplying water to the groundwater. Now, the other way around, groundwater, when it supplies water to the stream, then those are called effluent streams. So, influent stream is when water from the stream recharges groundwater, and effluent stream is when groundwater provides water to the streams. So that is why the answer here is streams that contribute to the groundwater, influent streams. Water is going from the stream into the groundwater. They are called influent streams. There are other terms here called perennial streams. So just let's have a look at that also. So perennial streams are nothing but streams that are flowing continuously throughout the year. So whether it is monsoon or summer, whatever season it is, if a stream lasts for like in spite of the wet and dry spells, then it is called a perennial stream. Like perennial trees, the evergreen trees are called perennial trees. Same, lasting for long. Now, the other term, ephemeral streams, are nothing but when there's a heavy precipitation occurring, then these streams will start flowing. They'll have enough water, but then this water is going to be drained as soon as the precipitation event is over. And such streams are called ephemeral streams. Now, what is intermittent streams? Intermittent streams is nothing but, again, when monsoon season is occurring and when there's precipitation and a lot of rain, these intermittent streams will be there. But they'll last a little longer than the ephemeral streams. That is, they last for the entire season probably. Ephemeral streams are not like that. They're not going to last very long. Generally, they flow less than 30 days per year. But intermittent streams will last for a little longer than 30 days, maybe for the entire season. So such streams are called intermittent streams, where the seasonal flow is detrimental of the stream flow. Ephemeral stream, where the precipitation event is detrimental of the stream flow. Perennial streams will flow throughout the year with no impact from wet or dry spells. Next question. The rate of groundwater movement is given by conductivity, hydraulic gradient, storage capacity, both A and B. Right? So correct answer is D. So let's check into this terms of conductivity and hydraulic gradient. So there was an earlier question which said that high porosity of the soil is sufficient to determine the yield of water. And I had talked about permeability. This is where the permeability comes in. So when you want to know the rate at which the groundwater is flowing, we have to know about the conductivity, hydraulic of the aquifer, as well as the hydraulic gradient of what is a hydraulic gradient exists. So Darcy gave this equation called the Darcy's equation, which relates the velocity of the groundwater flow as a product of the hydraulic conductivity and hydraulic gradient. Now, hydraulic conductivity is the way in which permeability of an aquifer is expressed. Permeability is nothing but it is the ease with which water can flow through the aquifer. How easily water can flow through the aquifer is what is determined by its property called permeability. Permeability mathematically is expressed using the letter capital K, and it is called hydraulic conductivity. If it is highly permeable, you can say the hydraulic conductivity of the aquifer. So velocity is given by the product of the permeability, product of the permeability and the hydraulic gradient. Now we all know velocity is related to discharge and area in this way. It is discharge divided by the area will give us the velocity. So we also know that velocity is equal to K into I, product of hydraulic conductivity and hydraulic gradient. So we can get the discharge by K into I into A. So if they are asking for velocity, it is K into I. If it is discharge, it is K into I into A. So let's see what hydraulic gradient is. So if you see over here, we just now saw how Q is equal to K into I into A. We are familiar with what K and A is. This I is given by delta H by delta L. Delta H is nothing but the pressure head loss. That is, suppose you, if the water flow is in this direction through this aquifer, and if the pressure at the this initial area is this much, say H1, and when it starts, when it reaches this point, the pressure head is H2, then difference between this pressure head divided by what length does the water flow is called the hydraulic gradient. So I is equal to delta H by delta L, or sometimes written as L, delta H by L. So we learned what hydraulic conductivity is. It is the expression of permeability. We learned what hydraulic gradient is. It is the ratio of the pressure head loss to the flow path. And A is the cross-sectional area of the aquifer. So in this question, what is the change in the head per unit distance called as? Is it called as the hydraulic gradient, equipotential gradient, flow gradient, or hydraulic head? So we just now looked at what hydraulic gradient is. Yes, it is correct. The option A is the answer. Hydraulic gradient, I'll just go through those slides once more. It is delta H by L. Okay. So the correct option is A, hydraulic gradient. Again, this question is about Darcy's law. What is the Darcy's law? Does the Darcy's law say that the discharge is inversely proportional to head loss? Or does it say that discharge is inversely proportional to head loss and directly proportional to the length? Bring the equation into mind and make sense of the statements. Correct. Discharge is directly proportional to head loss and area of flow and inversely proportional to length of path. So we had seen how discharge is K into I into A. I is equal to delta H by L. So Q will be equal to K into delta H by L into A. It is directly proportional to the hydraulic activity, pressure, head loss. and cross-sectional area and inversely proportional to the length of flow path. So the correct answer is option D. Next question. What is the velocity of flow of water through a soil stratum of permeability K and porosity N given by? Correct. So option A. We learned how P is equal to K into I. Q. This option. If it was Q over here, it would have been right. Ki into A. So option A is the correct answer. Next question. When groundwater flows into a stream to augment its discharge, then what is the stream called? Okay. Let me take you back to previous slides. Option is B. So we had checked over here what an influence stream is, what an effluent stream is. Influence stream is when the stream is providing water into the groundwater, and effluent stream is when groundwater is providing water into the stream. We also checked what ephemeral is. A very short periods of time only the stream will be there. Intermittent stream is when it will be available during seasons, and perennial streams are water available throughout the year. So here, when groundwater is flowing into a stream, it will be effluent stream. So the correct answer is option B. Influent stream is when water is flowing into the groundwater. Stream say groundwater, it will flow, water will flow to the groundwater. That is an influent stream. Perennial stream throughout the year. Ephemeral stream for small amount of time. Now, what is an aquifer which is confined at its bottom but not at the top pore? Is it called a semi-confined, confined, unconfined, or none of the above? I mean, this confined and unconfined aquifers have been repeatedly discussed in the previous sessions. Right? Oh no. The answer is C. A confined aquifer is when its top and bottom is confined. That is, top and bottom there are impermeable layers. Unconfined aquifer is when only the bottom has got an impermeable layer and water is accumulated on the top. There is no confining layer at the top. So the correct answer is option C, unconfined aquifer. The last question, what is an example of an acutard? No. Let me give you the examples of all kinds of formation. So here you see aquifer, like I said, is formation that can significantly hold water also. It can provide water also. It can yield water also. Some examples of aquifer is sand, gravel, etc. Now, acutard is a formation which can hold water, but water cannot transmit to it, flow through it as easily as an aquifer can provide for. So, acutard holds water, but the yield is very insignificant when compared to the aquifer. So, what kind of geological materials forms acutard is when there is a sand layer and when a small clay layer is embedded in this sand layer, or a clay lens is embedded, a small portion of clay filling is also interbedded with the sand layer, then such formations are examples for acute tard. Acute fluid is nothing but it is when it's a very impermeable formation. That is, water will be there inside the material, but if we cannot get water, we cannot. The formation does not yield water at all. And examples for acute fluids are clays. Acute fuge is the formation where no water will be there. You cannot store water, you cannot transmit water, no water will be there because those are materials like granite, which is very cemented together. So there's no space for water to be available there. So correct answer is sandy clay. Like I said, acute arts are formation where in sand there will be some clay portions. So in clay portions, when the sand portions are there, it is those are called as those are examples for acute art. Granite rock is an example for acute fuge. So that's all we have for today in the question discussion. Karthik, if you have any doubts regarding whatever we have discussed now, you can ask me. I'll be here for some more time. So feel free to ask any doubts. You don't have any doubts, you can feel free to leave the session. Okay. Then you can leave the session. Karthik, thank you for attending the session. I'm sorry, Karthik, I don't have information for quantitative aptitude. If I get any, I'll share. Karthik, if you have any doubts regarding this session, do ask, otherwise you're free to leave the session. Okay, so yeah, do you want me to discuss the questions once again? Yeah, sure. So please try joining earlier because I already finished 2 rounds of discussion, but it's fine. We'll just go through it really soon. So if you want, you can type the answers. This is the first question. What is the quantity of water that a unit volume? 7 and 10. Okay. Yeah. 1 second. Okay. So seventh question is talking about the upper surface of a confined aquifer. So let me take you to this slide. So a piezometric surface or a potentiometric surface is nothing but when you find the pressure head. Three questions. I'm sorry, but no, I'm not supposed to be discussing assignment questions until the solution is arrived. Assignment 3 questions you're yet to submit, right? Um, um, is the assignment 3 submitted? Okay, so I'll be only discussing sample questions. I won't be able to discuss the assignment questions until the solution arrives. Solution is out. Okay, I'm not aware of it. Let me see. Just a second. Submitted the assignment, right? It's supposed to be due on 16th August. So that date is over. Okay, I'll see what the question is. Which model is commonly used to assess aquifer vulnerability okay, by considering parameters like depth to hydraulic and net recharge? Yeah, I think it is Hydrus model. Hydrus is one model that is capable of simulating water transport one-dimensionally, two-dimensionally, or three-dimensionally through unsaturated porous media or saturated porous media. So generally, Hydrus model is what is used for uh, in my knowledge. I don't know about WQI and drastic and SWMM model. In the next class, I'll give details about those. Then 10th question is what is, but correct answer given is not hydrous. Okay, let me just, I haven't gone through these questions. Let me just check these questions once and I'll be discussing the answers in the next problem solving session. 10th question is what is the term used to describe the area above the water table where soil pores contain both air and water? It is unsaturated zone. C. 10th question is option C. Again, hydrous model. It is talking. Okay, that can also be the answer. You're right. Term which describe the area above the water table where soil plus contain both air and water. I think it is unsaturated zone because capillary zone is coming. No, unsaturated zone also contains water. It doesn't mean that it does not contain water. Unsaturated zone is the zone which is consisting of pores where air is also there, bit of water is also there. When all the pores are completely filled with water, then it is called saturated zone. Capillary zone is that portion of the water table, I mean, just above the water table, where water movement happening is because of the capillary action of those pores. So, since there's no mention of whether it is a capillary action or anything of that sort, I think the most appropriate answer would be unsaturated zone. Maybe you might have got confused because they have asked above the water table. They haven't mentioned just above the water table. Any layer above the water table is coming under the unsaturated zone. That unsaturated zone is divided again into three categories: the soil water zone, intermediate zone, and capillary zone. Soil water zone is a saturated portion in this unsaturated zone. Intermediate zone, capillary zone. We can't say that it is. Uh, it also comes under the unsaturated zone. So option C looks like the most probable answer. Okay, about the seventh question, I'll just go through all the models. I'm not very sure about all the models. Hydrous, I know. Drastic model. Okay, I think I will be wrong when I say hydrous because hydrous is not considering hydraulic conductivity, yes. Depth to water table also, yes. But net recharge, um, I'm not sure. Drastic model, but considers all the three. I'm not very sure about the net recharge part in this seventh question. Let me just look into all of it and then give you a proper answer in the next session. I'm not sure. Is that okay, Ranish? Thank you. Do you have any other doubts regarding today's session? I'll be uploading today's session's presentation and YouTube video very soon. So you can go through it, and if you have doubts, you can post it in the forum also. Thank you, Danish. So that's it for today's session. Thank you everyone for attending this session, and we'll see the next week with just question discussions for the topics that are covered in the week 5 lectures. So until then, bye, and everyone have a great weekend. Thank you and bye bye.